Hi, my name is Michael, and this video is about the Liberate protests, more specifically, the protests that occurred during April 2020 in response to quarantine efforts in the US. So this video will be talking about examining online dynamics of the protesters against US COVID quarantine measures on Twitter. And all of the work presented in this video is from the recently published article in Online Social Networks and Media, which is a scientific peer review article. So just for some background, so we collected data from tweets on the Twitter API using keywords related to COVID-19. So COVID-19, Corona, coronavirus, etc. We also added another filter looking for specifically the word liberate. And we collected the data between April 1st to April 20th, 2020. And on the right is a little bit of a diagram that shows kind of the data collection process in a more diagram format. So as you can see, on April 17th, after Trump set his tweet, the amount of tweets that were related to the data set spiked up. So this was specifically Liberate Virginia and Save Your Great Second Amendment. It is under siege. So we looked at, we content coded up to 3,830 unique tweets within a total 19,000 or so data set. So we looked for supporting protest sentiment. So this is just if the tweet does support the protest, such as, liberate our country in all caps, so governors headed for messy fight over coronavirus restrictions. Then we have the category of against protests. So these are tweets that are, against the quarantine protests. So we have, these are acts against the United States, aka treason. And then we just have another category of just plain reporting of the protest. So just stating that it's occurring, but not really adding an opinion on it either or. So we classified users as protest supporters if more than 50% of their tweets showed a positive reaction towards the Liberate protests. Then to kind of identify larger themes within the discourse and the data set, we used what's called the bit term topic model. So this is a natural language processing approach. It's more in the unsupervised machine learning category, and essentially clusters all the tweets together based on their textual similarity. And just a little context of how bit term topic modeling works, as opposed to more traditional NLP approaches that uses like a unigram or bigram. So just like one word at a time or two words grouped together at a time. Bit term was designed specifically for looking at short Word documents, such as a tweet, which only is limited to 280 characters. So what a bit term exactly is like, so you have the sentence, go to school. So that would be 3 bit terms where it's go to, go school, and to school. And essentially, this just helps the algorithm detect the co-occurrences of words within the different documents, which are the individual tweets. So then once we clustered all the tweets into different topics, we looked at the most influential tweets associated with each topic cluster and then filtered the data set based on some criteria that's more in-depth in the paper. But it's basically, we filtered out if it was reporting on, or just tweets that were related to just reporting the news of the protest, or if they were related to more viral videos, which are more specific incidents to the protest, but not really indicative of people's more larger views towards the actual protests. So in total, we had 10 topic clusters that we used for further analysis that met the criteria that were, that we decided that were relevant to the discourse. So there was 4 main categories in total. These are the first 5 topics, and the next 5 topics are on the next slide. So all of these topics for the first 5 all showed predominantly were majority against the protest. So they were, anti-protest dominant. And the main themes, that were included within this discourse, we have backlash against protesters. So these are just critiques especially towards protesters in general. Then we have backlash against the Trump administration. So the topics 2 to 5 all are more in this category. So an example of that, is so these are critiques specifically towards either President Trump or his administration. So in topic 3, we have an example where it's like, somebody please liberate America from this corona spreading clown. So just give an idea of what those tweets are like. Then for the other 5 topics, we have a backlash against Fox News topic. So this is again just critiques specifically towards Fox News as a broadcasting channel. and kind of more incorporating them with the Liberate protest. And then we have the two topics that are predominantly show support for the protest. And these were both categorized as Liberate America, since that just seemed like the common theme across the two discourses. An example of that, this is, in topic 7, the first tweet we have, subpoenas Google for Clinton emails. Real Donald Trump should appoint special counsel to investigate Clinton, Obama, Biden, plus Liberate America from coronavirus shutdown. So this tweet kind of, brings up the email scandal from 2016 related to the Hillary Clinton campaign, but then also ties it in with the Liberate protests that are happening in the moment of during when this data set took place. And so to kind of look at the two topics in a little more detail, as you can see, so even though there's only two topics that are predominantly supporting of the protest, up to over 40% of all the total volume of the tweets that were analyzed were related to these two topics. So even though it was more centralized in terms of topic or theme wise, it still takes up at least over 40% of the data set. Then we also looked at another metric developed for this study that we called echo scores. So this would just kind of get an idea of how much is the same message just being replicated throughout these different topic clusters. And this is kind of just to capture a little bit of and see if there's an echo chamber effect going on. So this is just calculated by taking the total number of tweets that were associated with each topic and dividing it by the number of unique tweets by the topic. So an echo that's closer to 1 signifies higher number of unique tweets, while larger values of echoes shows high replication of the same message going on in that discourse. So as you can see, when you look at topics 7 and 10, they have much more echo than the against protests topics for the most part. Topic 7 actually has the most echo compared to the entire data set. Number 10 is actually number 3 in terms of echo, because actually topic 9 does have more echo happening in that discourse. So it's not necessarily completely unique to the protest supporter groups of having the echo, but it seems like, at least from the two topics that were analyzed in this study, two of them did have, these two pro-liberate groups or topics did have a lot more echoing in general. Then to look at the breakout of protest supporters versus against. It was 53% were against the protests, or we classified as against protests, and then we had 44% as protest supporters. Then just kind of comparing some behavioral attitudes between them. So we have protest supporters were more likely to include a URL, especially that URL being from a Twitter link, so more likely to kind of retweet someone. But they're less likely to have that URL be associated with a media source. And they're also less likely to produce a unique tweet. So instead of just retweeting without adding commentary, where the non-supporters were more likely to kind of add a little bit more text to when they're contributing to the discourse. So now we're going to kind of dig into the social network analysis aspect. So in this just shows kind of the overall network. And granted, this is just, we use an algorithm to kind of select a choice amount of nodes to display, just because there's too many nodes to fit on a screen. So we have the red nodes that are protest supporters, the blue nodes are non-supporters, and the greater size of the nodes indicates the higher number of retweets that node received. So, that big middle red node in the middle, that was retweeted probably like the most compared to the other nodes. And then this image kind of just shows the differences, or we teased apart the two networks just to kind of compare them visually. So as you can see, like the protest supporter network, has fewer bigger nodes, so less, like lower number of influential nodes, but those nodes do seem to be bigger in general, so they are more influential. And as you can see, like there's a kind of more of a broadcast centralized discourse going on, while the non-supporters, there appears to be more, or at least based on the visual observation, there's some statistics on the next slide that we'll go over that shows a lot more discourse going on between them, and there's a lot more number of influential nodes. And so this is backed up by the stats on this slide. So if you can see in the middle table, we look at the degree distribution. So this just shows the number of times of out degree, which in this study is the times of how many times each node was retweeted. So this shows the number of influential nodes. So these are just nodes that were retweeted within this discourse. So protest supporters, there were 15, while non-supporters, there was 105. So this aligns with on this slide where, there's lesser number of nodes over here, where there's a greater number over here. And then if you compare, if you look at the mean, max, and just the general degree distribution, you can see that the protest supporters are just retweeted a lot more often compared to the non-supporter influential nodes. Then to also kind of add some inferential stats to this as well, we use an exponential random graph model, or an ERGM, and that essentially does is takes the network and basically determines whether a network structure is statistically significant by taking the number of nodes and calculating every possible network that could be constructed based on that number of nodes, and then seeing like if the network that's being observed based on the parameters you add are actually like unique, or if it like and being statistically significant, or if it would be more typical to that type of to a network structure of those number of nodes. So we use what's called geodesic weighted out degree. This essentially just is the number of times they were retweeted, and basically it looks at how uneven the distribution of the retweets were. So for both protest supporters and non-supporters, both were negative, which shows that the more negative it is, the more uneven the distribution is. And both of these are statistically significant. However, the protest supporters are more negative, which shows that that network did have a much more uneven distribution compared to the non-supporter network. And then just for a little deeper dive into the influential nodes, so again, there was 15 protest supporter influential nodes compared to 105 of the non-supporters. And we looked at media occupations that are just information that was available on their Twitter profiles. So protest supporters were less likely to be from a media outlet, or whether they're identify as a journalist, news show, author, etc. While the non-supporters were 23% more likely to be from a media-related occupation. And then comparing the retweets from influential nodes, the non-supporters were 40% more likely to retweet from a media node, while 89% of the protest supporters were retweeting from a political org node. So just for a summary, so this study analyzes online discourse around COVID, Liberate supporters and opponents. The pro-Liberate network was more centralized with higher volumes of replicated tweets, and the influential pro-Liberate users showed a greater association with political organizations. The anti-Liberate network was more decentralized, thematically diverse, and more media-driven, or there's a lot more influence from the media. And the study also introduces this echo measure just to kind of look at message replication and try to get a little bit at echo chamber effects on social media. And if you're interested in learning more about this study, the citation for the paper is below if you want to learn more details about how the methodology was carried out.